Okay, hello everyone. Come on, more energy. I know it's 5 p.m., but we still have two more talks. Come on. Hello. React Alicante, thank you so much for having me one more time. Before anything else, once again, thanks to the organization. Now, I know that you gave a huge ovation when Facundo asked you to do that amount of noise, so I'm going to ask you to do the same thing, but now for the organization, because they have done an amazing job having all these amazing speakers so far, and we're still halfway through, so we still have one more day tomorrow. So, a huge ovation to the organization. Come on. Okay, so anything else? Sorry if my voice sounds a bit low, but I had a 4 hours workshop yesterday. Who is here from yesterday from my workshop? Okay, you spent 4 hours listening to me yesterday and you're still here today. Thank you. So for those of you who were there might be some spoilers on this talk. You might have been spoiled over a couple of things, but well, hopefully you'll still enjoy it, and all of you that were not there, you're about to learn about the story that happened to me and my team. So let's start the story, and let's start the story with something that I hate as a developer. There are three things that I hated as a developer, and the first one is whenever I have unmaintainable code. You know that thing, right? The more code you add, the worse it gets. You look at your code, you feel like throwing the laptop out of the window and quitting your job and changing teams or whatever. This is the feeling, well, that hates. Oh, there's something there, let me just choose what to show. Because it's annoying me, and it's probably annoying some of you as well. Let's just take this out of here. So, yes, I was saying, unmaintainable code, the first thing that I really hate. What's the second one? Unmaintainable tests. When this unmaintainability goes out from the code that you're developing, it crawls in your tests. What does this mean? Well, it probably means that you're not going to be able to sleep well at night. It probably means that the things you're building are flaky, hurt you, and they are not doing what they should, which is making sure that the things that you have are safe, are working, and give you the confidence. And the third thing that I really hate as a developer is when tasks arrive late during a sprint. This is a bit specific, but let's picture a scenario that you have a sprint, 2-week sprint, something like that, and you have a task that is shared with another coworker. Well, in this specific scenario, one of the things that happened a lot to me was the other coworker that picked the task first, typically they had to build an API or something that they were going to do, took 98% of the time to do the task. What does this mean afterwards? It means that then the other 2% was the time that I had to expect to finish that thing. So obviously my project manager expected me to deliver it yesterday. So these are pretty much the three things I hate. I could be ranting about this one a bit more, but let's not do that, because I have a story to tell you. I have a story to tell you about how me and my team got rid of all these three things. And this story, let's start at the beginning in this case. Me and my team had just defeated the unmaintainable code monster. We had slain that thing. Now, you might be thinking, okay, but why? What happened? What the heck was happening in your code? Well, there was a scenario here that I'm going to tell you. The issue was server state. Now, I don't know if you're familiar with server state. Typically, the type of state that exists somewhere on a database. It's asynchronous. There's no control over if it's up to date or not. And, well, me and my team, we had to implement something to deal with it. So, what did we do? Well, we just went ahead and did all the code ourselves. We were adding code to deal with stuff like, well, caching, data prefetching, doing other stuff like optimistic updates, pagination, a bunch of stuff that it's not even named here. But we were implementing code to do all of these things. Man, it was terrible. We were not... The more code we added, the more were feeding the monster that was there. The worse in our code and the more unmaintainable it got. Now, this was when we started questioning ourselves, when we started thinking, well, perhaps we shouldn't be doing this. Why are we implementing these things for our own? Why aren't we doing anything else? Why aren't we using perhaps a library that someone already built, tested, published, maintained, and it's probably going to be way better than the crap that we're building right now? And this was when a coworker, like King Arthur in the movie The Sword in the Stone, I think that's the name, went to the stone and pulled our Excalibur out of the stone. And in this case, our Excalibur was 10-stack query, or React query. Remember that in Roy's talk he mentioned about if we should say 10-stack query or React query. I've asked, the answer is If you're using the React adapter, you can still say React query. The 10-stack query, it's the container of it. This is just a side note. But yeah, 10-stack query brought harmony to our kingdom. Everything seemed to be better because now we were able to delete all that code we spent months implementing. That was not that good. This thing just made it way, way better. So 10-stack query brought harmony to our kingdom for a while. That is, because a threat was working in the shadows. The unmaintainability from our code disappeared, but found a way to crawl into our tests. Now, you know what they say about the Hydra. When you cut ahead, 2 more take its place. And this was kind of what happened with us, because now our tests were not just unmaintainable. They were flaky, they were complex, and we tried many options to get rid of this thing. We tried to get out of all these approaches. Heck, I'm pretty sure we even resorted to witchcraft at some point, but it didn't work. And it's funny, because this story, after a couple of years, all I needed was a contract. So before I go on, let me just do a quick introduction. I'm Daniel AFONSO. I'm this guy here on this side, just in case you're not able to recognize me. I'm working as a developer advocate at OLX. I'm a NegEd.io instructor, an Alt0 ambassador. And you can find me on Twitter, X, whatever you want to call it these days, at the handle Daniel GC AFONSO. I also wrote a book on state management with React Query, so it was released a couple months ago. So if you want to learn a bit more about React Query and all those things, you can chat with me as well, and I would love to take your answers. Another thing, I think we should always give back and help others. And I want to thank these people that helped me review this talk. So one of them you might recognize because he was just on stage a couple of minutes before. This guy is the guy with the glasses. So thank you to Mateus and to Josh for helping me get feedback, review this thing, and tell me what stuff they thought and they liked. So I would be able to build this talk in a better way for all of you. So can I get an applause for all of them? Okay, so before we continue, let's just say something once again. This is a case study. So throughout the presentation and throughout what I've been saying, some of you might be thinking, yeah, probably I would have done that differently. Well, now if I knew what I did back then, I would have done it different as well. But that's the thing with development. We don't always have the answers when we need them. So let's just recap what was happening. Let's recap and put ourselves in the issue. We fixed the unmaintainable code because now we brought 10-stack query, React query into our project. Everything was way better. But now our tests started breaking. We started breaking because we were having issues testing stuff with data fetching. Now, before we continue, let's just recap what happens traditionally when you do a request in a very simplified way. So we have a browser and we have the internet. So what happens typically is that you do a request to the internet, right? And then what the internet is going to do is going to return some data. Now, if you're going to talk and we're talking about tests now on testing environment, we probably shouldn't be doing this because if we're going to the internet, we're probably going to get not always the same data set. And when we're building tests, we want to make sure that the test that I built right now, the test scenario is going to be the same tomorrow because the data should not change. So in this case, what we should expect is to have a way to have some mock data for this case. So what did my team and I do that ended up causing all these issues? Well, first, we started with manual mocks, right? So we started to do some jest FN stuff, some jest mocks, some jest spies, a couple of things. And it worked for a bit, but the more our code grew, the more these things showed up, and the worse it got. Then we started doing some stuff with Axios as our client, and now we said, okay, let's add Axios mock adapter into the mix. Let's have both them at the same time while we try to migrate from one scenario to the other, but let's keep maintaining them. And once again, the more we added, the worse it got. And the worse it got, the less we slept that night. This was when we probably, at that point, we still added something like magic. To this day, I still have no idea what the heck that code was. All I knew was something. Every time I changed something on a manual mocks, it would break Axios mock adapter. Every time I changed something on Axios mock adapter, it would break something on the magic. And you guessed it, every time I changed something on the magic, it would break the magic mocks. So, yeah, it was tiring. It was frustrating. We weren't able to sleep well at night because at the end of the day, we didn't have confidence on the tests that we were writing. I wanted an ideal world. I wanted something that made it easy. I thought about it. So every time we're developing, my team was separated in backend and frontend. The backend develops a contract. This contract specifies the API and the schema and the data that we're going to get from it. Well, in an ideal world, I wouldn't have to do any of those mockings. In an ideal world, I would get my contract, and this something on the internet or something on my project would let my tests and my components do the requests, and something according to a contract that I specified would return me the data. And, well, back then we didn't know what to do. We didn't have any tools. We didn't know what solution we should go with. And this is when something like mock service worker showed up into our lives. And mock service worker pretty much ended up being the thing that fixed the issue that we have. Now, I'm going to ask you to pause a bit on the story, because now I'm just going to give you an introduction to all of the fundamentals of mock service worker. And I promise it's going to be quick so that you understand how it works. Mock service worker is pretty much an API mocking library that uses and leverages service workers to intercept your actual requests. So, how does this thing work? Typically, once again, when you have a browser, you request your data, the data from the internet, and the internet returns the data back. Normal. Well, mock service worker introduces something into the loop. Introduces a service worker. Service workers run on the browser. We don't use them. We should use them more, but we don't use them that often. And the way this thing works is, we specify a contract, and this service worker, every time there's a request, service worker is going to intercept it. It's going to look into the contract that we specified, and it's going to say, okay, for the route that we're doing this thing, do we have any mock data of source? And if so, we return it. Pretty much it. Now, some of you might be asking or thinking about, okay, but what happens on the scenario that we don't have a route defined? Well, what mock service worker will do is it will intercept the request, check its contract. If nothing is defined there, lets it go into the internet, gets the actual data, and sends it back to the user. Pretty much it. This is the standard way that the mock service worker works on the browser. Now, to specify a contract, to specify how mock service worker works, sorry, it's a funny word, we need request handlers and we need response resolvers. So request handlers are the things that are responsible for defining your route. So let's look at this example that we have here. Here we are importing REST. So pretty much we're thinking that we're probably building a REST API. So what we do after? We say, okay, whenever there's a GET request to the route Daniel JC AFONSO, we're going to return this response. We're going to return this response resolver. We're going to execute this thing. Pretty cool, right? What's cool about it is it also works for GraphQL. So you don't need to be only using REST. If you're using GraphQL, you can still try mock service worker as well. So you have your GraphQL imported from here, and you can say, okay, whenever there's a query for GET users, we're going to run and return this response resolver. Pretty much the flow for request handlers, all that you need to know right now. Looking at the response resolvers. So the response resolvers are the things that go inside of your request handlers, and it's pretty much a function that receives a request, a response, and a context. And in this scenario, what we're doing is, okay, whenever there's a GET request to Daniel JC AFONSO, we're going to return a response, which is going to be a JSON object with first name John and age 38. That's what we're doing here. And this is pretty much the base of what you can use mock service worker for. You can do this for GET, for POST, for delete, whatever. If you're using REST, you can do whatever for GraphQL as well. And this thing is super powerful. So how does mock service worker run? Because so far I've been talking about service workers, and some of you might be aware of this, but service workers supposedly only run on the browser. So mock service worker can run on the browser and it can run on a node environment by using two things. If it's running on a browser environment, service workers. Don't worry about anything else. If it's running on a node environment, it actually provides a node interceptor package that will do the same thing. So it's in its essence, it's still going to do the same thing. All you need to do is, if you want to set up your service worker, all you need to do is call setup worker and start it before you run your application. If you want to run this on your tests, all you need to do is call setup server and listen. Let's look at an example of how to set up the service worker. We import setup worker from here. We import REST. We define, inside of our setup worker, we pass our request handler, and then we say worker start. And what this will do is once your application starts, mock service worker will start running automatically. So what's the flow of that this thing does? So let's see an example and recap it once again. So here we have a browser, a service worker, and the internet. Imagine that we have a GET request to Daniel GC AFONSO, which is the request handler that we set up. What's going to happen is mock service worker is going to intercept this thing. It's going to ask itself, do I have a defined handler? It checks the request handler, so we do, right? Inside of that request handler, what's the data that we have being returned? It's the JSON object, so it just returns this thing. Pretty much the same flow they already repeated. The same scenario that I mentioned previously. Imagine we go to a route that does not exist, in this case, a GET request to random. Mock service worker is still going to intercept the thing. After asking it, asks itself, do I have anything defined? It's going to say, we don't, so let's do the request to the internet and return it. And congratulations, you just learned mock service worker. You're ready to go home and try this thing out in your browser in your tests. So now it's the part where getting back to the story and what happened, because of how mock service worker works, we soon were able to understand, okay, now perhaps we can do the thing that we always want, which is save our tests. All we needed to do was 3 things. First one, delete all the mocks. Delete all the access mock adapter, all the manual mocks, delete all that magic and things that I have no idea to this day still what it does. Create all the request handlers with the respective response resolvers. And then start the server. And that's pretty much it. Then we would run our tests, and mock service worker would just intercept the requests, and it would work. Just like that. And I've seen a lot of talks and a lot of discussions about beers. Yeah, this is kind of us afterwards, once we saw that thing working, because now we were able to stay still, have a beer, and rest at the end of the day. Because now our tests were working, and they were not unmaintainable anymore. We didn't have to worry. They were not flaky because we got rid of all the bad mocking stuff that we were doing before. So one of the questions that I've been asked a couple of times when I did this talk is, why not build a mock server instead? Why not go ahead and just build a mock server? Well, there's 5 answers to that. First one is, it required changes to our systems. If we built a mock server, what we would have to do is, every time we want to run our tests, we'd have to point our tests to a different URL. With mock service worker, we're still using the same things we're using in production. We wouldn't need to change anything. Second thing, every time you have to build a mock server, it's something new that you have to maintain. It's something new that you take responsibility, something new that you add into your tools. Okay, it's fun to build these things a couple of times, but after a couple of days, it gets tricky. And the more complexity it adds, it's something new, something that can break and can cause friction to your team. And another thing with mock service worker, there's kind of like no build time need, and there's a very low maintenance effort to it. The third point was, there's an extra configurations for different environments. So what I mean by this, and environments and testing behaviors, what I mean by this is, imagine that you had a test scenario that you wanted for a specific route. When you do that request, to test an unhappy scenario. Let's picture that you want to test a scenario that your server throws an error. Well, typically what we would do when I was building mock servers is we would have to customize our route, add a query parameter in there somewhere in the process and say, okay, whenever we receive a request to this route with this query parameter in this mock server, we're going to return an error. So this meant extra configurations that we had to bake in instead of, well, just using mock service worker that you can do this thing directly in your test and without extra configurations. Pretty much easier. Another thing that happened a lot to me was accidental test leaks. So imagine that, for instance, you have a test that would, for some reason, crash the mock server. This would mean that all the tests that went after would break, would fail as well, because your mock server was already down. And this would mean that you would have accidental test leaks sometimes. And with mock service worker, we didn't have to worry about this thing, because each test was its own test. And finally, pipelines. Configuring this thing to run on pipelines, make sure that this thing starts when we start our test is something that we had to make sure of. And with this thing, we didn't. You saw it. All we needed was a setup server and a listen. That's pretty much all we needed. So if you thought about this difference between building a mock server compared to using mock service worker, now you should be a bit aware of the differences between both. Now, I told you that before that there were 3 things that annoyed me, and so far we only got rid of 2. The third one was when the task arrived late into the sprint. And the fun story is that mock service worker ended up fixing this thing as well. It seems a bit weird. You might be thinking, how? Well, let's recap the fun thing that was happening in my team back then. So we had a 2-week sprint. And in this 2-week sprint, we had 2 parts of my team, like I already mentioned, back-end and front-end. Cool. Now, let's review the objective of the sprint. Oh, the front-end didn't show. Okay. Let's review the objective of the sprint. We were supposed to build an API on the back-end and implement some UI screens for using that API on the front-end. What would happen would be that, in this case, my team on the back-end, they would take like all that time building the API. Well, it's not their fault. There's complexity to these things. They need the time to do these things with quality. There's responsibilities. There's a bunch of stuff that comes into it. But what this meant for us as a front-end was that while we were waiting for that thing, we could not work on the main focus. And so we had to do smaller tasks. We had to do smaller tasks. We had to do more small tasks. And then at the end of the sprint, there was this little thing. What's this little thing? It's the time we had to save the sprint. And I'm going to be honest, this caused a lot of confusion and mistrust with my team, because every time at the end of the sprint, the front-end part was pissed. Because we wanted to deliver stuff, we wanted to give stuff faster to our users. We wanted our users to be happy, and because of this, it was taking more time, and it was causing more pressure into us. So when mock service workers showed up, this kind of changed everything for us, because we should have thought this before, but we didn't. We thought, well, hear me out. We have mock service worker. And someone said, okay, we have mock service worker. This thing runs on the browser. Yeah, runs on the browser. You can customize a contract that's going to return mock data. Okay, where are you going into? What if, hear me out, right before we start the sprint, we all get together and we define the contract. Us and backend, we define the contract for our API, what data should we be expecting? And they said, okay, seems interesting, but why? Well, because now we can go ahead, mock all the data, and while the backend is doing the API, we can also work at it at the same time. That made everything so much easier, because now we had this mock data, and then all we had to do at the end of the sprint is just to make sure that everything pieced together, but we could pair up work. We didn't have to wait for the actual API because we could build some mock version of it. And the fun thing is we could test it afterwards. So this meant that after we do these things, so as you can see, the time still remained the same for the backend, but for the front end, we could finish this thing earlier, and we're very happy with other smaller tasks and without having to worry about anything else. And gotta be honest, this was the thing where everything changed, because now everyone was happy. There was no more confusion. Okay, stuff still took its time, but just one small change that the library could bring to our process ended up making sure that the team flow and the team happiness ended up being better. And there were only 3 steps that we had to do to save our sprint. Define a contract at the beginning of the sprint. Second one, create all the handlers using mock service worker. And then every time we wanted to, when we started our application, start the service worker and let MSW do its thing. And this was pretty much us celebrating after that on the retro afterward. We went for a couple of beers, we had fun, and everything flowed better. We fixed the 3 issues that we had, and mock service worker ended up getting rid of 2 of them. I'll show you some code example, but if you want to learn a bit more about mock service worker, the creator of it, Artem, wrote these 3 amazing blog posts on Haggett, where he goes over the process of HTTP requests, ways that you could use to intercept requests as well, and mock service worker. So these are all the things that led to the creation of mock service worker as a whole. So now I have kind of 8 minutes, so I'm just going to show you a very quick example. Let's hope my laptop doesn't fall from here. So we have here an application that at least some of you might be familiar from yesterday, but this application is pretty much an app that has a list of cars that you can see, and you can add them. In this scenario, whenever you click on My Cars, you're going to see a list of cars. And every time you come into this tab, there's a network request that's being fetched. And if we work into our network tab here, let's add this thing here and try to zoom in. When we did our GET request, you see here that there's a 200 OK, and it came from a service worker, because MSW is already working here, because mocking is enabled. So how is this thing built? Here, we have our application, and we have our handlers. And inside of these handlers, we have a bunch of request handlers. So what we do here is every time that there's a REST post request to this route, we return this data source. Whenever there's a post to this route, we return this, and so on and so on. But you can customize this even more. You can do a bunch of stuff. You get access to your requests. So if you want to get access to your cache, you can have access to your cookies. You can have access to whatever you have in your request. And even if you want, you can even do something funnier as well in some cases, which is you can also add the entire request, go to the internet, and when it returns, you can customize it or do some other things. This is just an example. So you can do a bunch of stuff here. And all you need to do is pretty much set up this request handlers file that we have here. For our tests, set up server. For our browser, set up worker. And every time we want to run a test, inside of our setup test file, we just tell a mock service worker, hey, start listening, start intercepting stuff. And if you look into our test file that I have here, let me go to a smaller one, pretty much there's no mocking of the network. So everything that we have here is just normal requests that are going to be responsible for loading data, for doing data fetching, and I don't have any type of mocking here, manual mocking, access mock adapter and stuff, because we just let the components be components and MSW intercept stuff at its level. If there are scenarios that we want to test some errors, for instances, we can override what we already defined. We can tell MSW, hey, look, for this specific test, I want you to return or do this instead. So you can customize this thing however you want for your testing scenarios. And this is for the tests. For the browser, all you need to do is start the worker whenever you're running your application. And you can comment this out, comment on, depending if you're in development. Probably you don't want to leave this going into production. But for development, for these scenarios, it's pretty much all you need to do is worker start. You run your application. Mock service worker is going to tell mocking enabled. There's a bunch of React errors. Oh well. And the requests are going to be intercepted and returned from mock service worker. And that's pretty much the behavior that we have with this thing. It seems pretty simple, and it's straightforward, and it saves a bunch of time. So now, on the last 5 minutes on this talk, I would like to leave you with some couple of thoughts that I've learned from this experience. And, well, it took some time to grow into them and to be able to use them, but the first message that I have to all of you is, our goal as engineers is to deliver amazing things into our users. And I feel like very often we forget these things, because personally I do this. We get lost into the shiny new things. We want to learn everything. And we get lost into the stuff of, well, let's just implement this thing instead of reusing it, or getting some package that was already built. This is something that has happened a lot. It's kind of the difference between the solution engineering and the problem solving, because we often get lost into the architecture and the DIY stuff of processes. I get it, DIY is amazing, I love to build stuff, but personally, now I try to do that in my learning time. If I can, there's higher chances that whenever I have an issue, someone else in this world already had the same issue. And probably they already built an open source package. Probably that open source package is well maintained and is way better written than the code that I'm going to do. It's secure, it's tested, and there's a bunch of stuff also there that I wouldn't be able to figure out. So I would like you to think about this, and think about this next time you have an issue and you think, oh, let's build a fix, or let's build this ourselves. Because if I had known 10-stack query earlier, I would have definitely saved months in my team, because we were dealing with a bunch of these server challenges issues ourselves, because we thought, oh, we can do this well. But the more we did, the worse our code got. And the same thing kind of happened with MSW. We were building a bunch of stuff, and if I had known mock service worker early on, or if we have thought about it earlier instead of going let's just try to find a way to build this, it would have been way better. And there's a funny part into it, there's a funny aspect. Because between all of these things and all this process and all the things that happened with mock service worker, all I needed was a contract. So with that, React Alicante, thank you so much for having me. Have fun.